Hey guys, so this is a quick little video of me explaining the continuity of functions. So continuity has three conditions and I already listed them here. The first one, the function value must exist. The second one, the limit as x is approaching that value must exist. And the third one, these two must be equal to each other. So in other words, the function value and the limit must be the same thing, okay? So the first quick example, I'm asking, is f continuous at x equals to 0? And this is f. So let's check the first condition first. Does f of c exist? Well, here c is your x value in question, which is 0. So I'm just going to plug in 0 into my function. So I'm going to have f of 0 equals 2. 4 times x, well, x is 0, plus 5 over 9 minus 3 times 0. You guys can already see that those go away because they are 0. So my answer is just 5 over 9. Okay, so my function value is equal to 5 over 9. Okay, so that is the first condition. It does exist, so I'm going to write a little check here. Now, does the limit exist? Well, let's find the limit. I'm going to say the limit of my function f as x approaches the value in question here, which is 0. Well, what is it? Remember, with limits, always try direct substitution first. If I plug in 0 to x, am I not going to get the same thing that I did over here? So these will go away. I get 5 over 9. So the limit does exist. So I'm going to write a check. Does it meet the last conditions? Are both of these the same? Well, they are. My function value and my limit are the same. So I can say that f of x is continuous at x equals to 0 because f of 0, which is my function value, is equal to the limit as x approaches 0 of f of x, or limit of f of x as x approaches 0. So that's sufficient. That is sufficient to say that you have continuity. Okay, you have to touch on all those 3 points, these 3 conditions. And the last example I'm going to do a little harder. You have a piecewise function, and I'm asking, is g continuous at 6? And is it continuous at 4? So let's do both of them. Let's do 6 really quick. I do want to say that if I said, if I didn't give you any x values here, like if I just said, is g continuous, you would just have to check for x equals to 6, because that is when your rule changes, right? Where your equation changes. But anyway, let's go ahead and start doing it. Let's do 6. So let's check for function value first. So g of 6, okay? And that's when you go back up here to your equations and you use the equation where x is equals to 6, which it applies for this x minus 1. And x is 6 minus 1, 5. So I get 5. Now let's do the limit. The limit of my function as x approaches 6. Now, notice that you do have a piecewise function and it does change at 6. This value specifically, you have to do from the left and the right, okay? So I'm going to go ahead and write it out already. Okay, so let's do the first one. 6 from the left. Well, which one applies to all the numbers to the left of 6? That would be the top one, right? So 2x. So I would have this limit as x approaches 6 from the left of 2x equals, and then just do direct substitution. Plug in x is equal to 6 and you get 12. So at this point, I already know it's not continuous at 6 because this limit is not the same as my value here. But let's just keep going. Now let's do from the right. Well, what equation fits 6 from the right? So all the numbers to the right of 6. That'll be the bottom one, right? X minus 1. So I'm going to go ahead and do limit as x approaches 6 from the right, x minus 1. And then just do direct substitution, plug in 6, and I get 5. Okay? However, since those two limits, the left and the right, they do not coincide, I can say that the limit as x approaches 6 in general does not exist. Okay, and obviously since the limit does not exist and this function value is not the same, I can say that g is not continuous at 6. So I can say thus g is not continuous at x equals to 6. Oh my god, it's so hard to record with one hand and write with the other. All right, so thus g is not continuous at 6, and I can say because my function value does not equal the limit as x approaches 6. And this is a parenthesis. Okay. And the last one, 4. Don't think too much about this one. This one, x equals to 4. Well, which equation does 4 apply to? Well, it's to the left of 6, right? It's less than 6. So you're only going to go ahead and do or use that one. So here I'm just going to explain it on video really quick. I'm not going to write the whole thing down, but the function value at 4, you just plug in 4. 2 times 4 is 8. And then the limit as x approaches 4 of g of x, well, 4 again, it only applies to this same equation. So you get the same thing, right? So your conclusion here is that the function g is continuous at 4 because the function value and the limit both equal to the same thing. Okay, I really hope this helps you out. If you need any more help, you can just reach out to me on Remind. Bye.